Guys, so this is very interesting because this question was posed to me. Who is right, Craig or Peter? And I had to look this up because they were still talking about how Peter was right. I had answered this, but I didn't know what a selfish minor alpha equals 1/3 was. And they're saying, so basically, they're saying somebody mined a block and they kept it hidden. So I was like, okay, regardless of whether they kept it hidden, right? If we're talking about starting here, what's the expectation of somebody else finding a block? Well, it would be 10 minutes would be the expected, value, right? Now, if you know that if somebody who's selfish found a block and then they hit it, then you're asking the question, starting from there, you know that nobody else mined a block yet. And then you ask, what's the expected time that somebody else finds a block? Well, if you know that nobody found a block at time t equals 0, right, the expected value always stays the same, right? So it's always 10 minutes, right? So if you know that nobody mined a block by now, it's still going to be 10 minutes. So that's why I said, t equals 10 if you're assuming that you know that nobody else mined a block by t equals 0. So that's why I just said 10, but I didn't really know what I'm not sure if I understood the question correctly. Now, they said that Craig Wright said it was 5 minutes, and somebody, Peter Rizun, 15 minutes. So somehow they're saying that this block is expected somehow from some context to either be 5 or 15 minutes, right? So we have this definition here on decentralized thoughts, and it's very interesting. They're kind of arguing for, I think, saying, I'm not sure if they need to have more than 1/3 of the hash power total, or what that means exactly. So they're saying if you do selfish mining, if you don't have enough, like, I guess, hash power or something, you make a loss. But if you have enough hash power, then it actually gives you an advantage, because then you start mining more blocks on the ones, I guess, that you didn't even publish. So then you can publish one, and it reduces the amount of time that somebody else has to build on the one that is published. And they're saying that the math kind of works in the favor of a selfish miner if they have enough hash power, which is very interesting. Like, that's a very, interesting point here. And that seems like it might cause sort of grouping together, of hash power of mining to be done. They start grouping together and working together because they say, hey, if we can group together and keep a secret block, we can share we can have one giant miner who controls everything and or who has the most power, But this is very interesting. I don't understand how this question is constructed, though. That's the thing that I don't understand this. I guess I don't understand how do you get 5 and how do you get 15? What kind of logic are they using to get that? Are they saying starting from here, but then we're reducing the situation to say we're assuming that the person who's mining the hidden block, out of all the possibilities, we're assuming that they find it first. Then what's the how much time does it take them to find the other block on average? That's a different question than saying we don't know who's going to get it first. We're just starting from here, and just how long will it take them, to find this, right? So defining the question obviously matters. So I guess the selfish miner only needs to have more than a third of the mining power. According to this article, this theory about selfish mining. So here's the miner size. I don't know if 0.5 is you have half the hash power of the entire network. I guess that's the idea behind a 51% attack, maybe, or something, is what they're saying. It's not just an attack, but it's like you can also just generate all the blocks and reap all the fees or something like that. Doesn't allow you to convince anyone else to build on your blocks if you don't have valid transactions, though. But it allows you to build, you know, maybe practically all of the valid blocks, because I mean, if you think about it, you have more than 50% of the hash power. It makes sense that you could just build all the blocks, because you essentially can have a longer chain than everyone else anyway. If you think about it, like, you can just build a long chain and you can just release. You basically, what you could do is just release as you're longer than the other chain. So as they try to build on the other chain, you just release one more, and you just make sure that your hidden chain is just always longer than, the publicly available one, I guess. The alternate, whatever the alternative one is, you just release in order to stay kind of barely ahead of them, like barely equal to them. If they ever build on it and try to make it longer, you just get equal to them again, and yeah, I guess that makes sense, because you could always, like, obviously you have more hash power, right, than the rest of the network, so you can just build you can basically just continue building your chain in private, no problem. Which is that's an interesting observation. That's easy to understand, I think. Third, though, this is the third point, and they're saying that as soon as you have a third of the hash power, that's when you want to start hiding blocks. Because it's worth it to hide a block and then try building on it, because you'll make more even though you're risking somebody else finding another block first. Very interesting. Very, very, very interesting. I like it. I mean, here's the thing. These BTCers, I want them to ask me questions like this. This is exactly what, this is actually what I like, because if people aren't asking questions, then they're being foolish. They're not wanting to they don't really care about learning. But when they ask me questions like this, and they're not just throwing mud, he can throw a lot of mud, but if he asks a genuine question, it don't matter how much mud he threw, that doesn't matter. Right? It doesn't matter, because it has nothing to do with whether the question is valid or not, or whether the answer is, what the answer exposes. So, yeah. Very interesting. I guess I can't. Blocks generated in 10-minute intervals. The attack starts right after a difficulty adjustment. Consider a strategy that results in a consistent rate of blocks that are pruned. Say 20% of blocks. results in a consistent rate of blocks that are pruned. So blocks are generated every 10 minutes in the system, but only 80% are in the main chain, making its block interval 12.5 instead of 10. Updates its difficulty. So basically the difficulty is based on just the chain, right? So what I think they're trying to they're talking about how you could have more mining than what's on the main chain. And that the main chain doesn't represent exactly what the hash power is. It represents like a percentage of it, I guess, because you have, the difficulty just looks at it's just constructed based on, the main chain. It looks back 2,000 whatever blocks, and it sets the difficulty according to that, which means you could have ghost blocks or whatever, but that doesn't count in this computation here. So that's very interesting. A third, that's very interesting. Because if you think about it, let's see. You have a significant. If you have a third, that means you create a block. They still have a chance of creating a block. But if you have a third of the hash power, I guess it depends where you start when you ask the question. Okay, so maybe their question is implying that the selfish miner has a third of the hash power, and that the honest miners, it's like 2/3 of the hash power. Right? So what I was thinking of didn't have anything to do with who has what hash power. It was just how long does it take somebody to find a block in general. Right? I just was thinking, okay, so I don't get what this has to do with it. Just its expected value is just 10 minutes. But I think what they're saying is you have a third of the hash power here, so that means 2/3 of the hash power is the rest of the chain, right? But regardless of whatever the hash powers are, the actual chain is giving you a difficulty of 10 minutes. So that's 10 minutes of on-chain blocks, which is interesting because you have to take that into account, because you could be generating, you could say, hey, you could try to compute a very crude hash power from that. Say, well, given, if we're all generating a block at an average of 10 minutes for 100% of the hash power, then that means, right? But that's not the case, because some people are hiding blocks. So you're actually generating more blocks, right, than what you would, total, than what you would have 10 minutes. So, if I had to guess, that means that you would, whatever the answer is, it would be less than the total expected amount. So say the rest of the hash power, say the total hash power gives you an expectation at time t equals 0, right? If you know there's not another block by then, well, then the entire, right, starting from this point, see, that's what I don't get. What is the question asking? Is it starting from this point or starting from this point? Because if you start from this point and you know no one else has mined another block, you still have an expectation that they're not going to find one. Right? And then if you find one and you publish it, you're publishing, you also found one that you're publishing, that you've used some of the hash power, to find Dude, this is a very interesting question, actually. I like it. Coming from a guy who seems like he just, like, you know, tries to pick on me and attacks me or whatever, it's actually a really fun question. It's really interesting, you know. I wish, you know, maybe more BSVers would ask some interesting math problems like this. This is really cool, actually. Maybe Jingles hates my guts. I don't care. You know, he's asking a fun question here, an interesting question. So, whether or not it's phrased correctly, I don't know. But it's still interesting to me as somebody who's not, you know, they say, you know, I'm not. Like, it's valid if they say, oh, he's a smart guy, but he's not aware of Bitcoin. It's like, yeah, but, you know, I'm going to say what I know about because that's, you know, I'm going to talk about what I know about, I guess. It doesn't mean I know everything about Bitcoin. Or that I've done all this math to, you know, study the statistics of all this stuff. But that's a very interesting question. A third of the hash power, right? They find another one, potentially. What is the expected time at which an honest miner will find a competing block at height n? And here's the thing. You find a hidden block, and then you have about 10 minutes on it to build on that hidden block, right? Assuming that you're competing with the rest of the... That's a crude logic. So assuming that you're competing with the rest of the chain, they might actually be slower than that. You might have more time. Okay, so I'm starting to see why you'd think that it would be longer than 10 minutes, because there's a chance that you find another one, and if you do, this one gets published, right? So it's not a block. So if you're counting it towards the total amount of blocks created per second, you know, or whatever, blocks created, you know, per minute or whatever, the rate of block production on the main chain, if you find the next one, you probably say, okay, well, I want to release this one. And then you can wait a little bit. You can wait a couple minutes, but you've already had a head start on finding the nonce of the next one, basically, is the point. But a head start, oof, this is very interesting. I like it. I like it, guys. This is like reminding me of like it's like I got a probability class all over again. I get to go back to old statistics, old probability. Get everyone's brains going. That's this doing a good job here. I like it. I'm just gonna put this video up, and I don't know. I might have some fun with this today, on paper or something, because it's actually really interesting. And I don't know if we have to assume that everyone else is selfish or honest, or could be one or the other. I don't know. Very interesting here. Very confusing. All right, guys. I'll just leave it at that. I like this. I really like this. This is really cool. Really cool question. I'm not totally sure I fully understand, but yeah, we'll try to examine this a little more. I wasn't sure if they were just messing with me at first. But all right. I'll see you guys.